Let's go ahead and get started. Just to recap where we've been, who we are, what we're doing, where we're going, I just wanted to introduce a few people. First of all, I'm Martha Bohm. I think I know all of you here, faculty member here in the department, and we're here for the HIVE CITY 1.5 review. This is the second stage of a sort of 4 or 5 stage process toward the construction of a habitation for some bees on the site of the grain elevators property, the American grain elevators property in downtown Buffalo. So today, as I said, we're in the second phase. Our first phase was a 1-day, some of you know we're participating in this event. It was a 1-day, 24-hour charrette to develop concepts for this bee habitation. So siting was fairly well prescribed. We gave a general location to be refined as the designs go forward on site. But to come up with concepts for habitation, concepts for structure, and concepts for form. And from that process, 10 teams were whittled down to 4 that we have today that we'll be presenting. And so what we'll see today is a little bit more development of those concepts, becoming a little bit more realistic in terms of the necessity of the habitation, what the bees actually require, and some of the logic of the structure. So what we'll see today is 4 presentations, 4 teams, 15 to 20-minute presentations each, followed by questions predominantly from the jurors to really understand exactly what the teams are doing so that we can evaluate and move forward into the next stage. And Joyce is going to be talking a little bit more about what the teams have done in this phase and then what the next stages are. But I did want to introduce our jurors for today. We'll be deliberating, evaluating the projects, and giving some comments to help the teams move forward. So joining us again, also from Phase 1, is Rick Smith, who's actually the owner of the property where the bees are currently and in the future going to be living. Thank you for joining us again. And then Philip Barr, who's our bee expert and beekeeper, who's given a lot of guidance to the teams throughout the process. Annette Lecoeur from our faculty joining us today. And Nerea Feliz, also from the faculty here in the architecture department, and Greg Delaney joining us. Brian Carter, who's also from our faculty, has agreed to give us some comments. And Dean Shibley, if you'll be around, we'd enjoy your feedback as well. Thank you. So I think I'll hand it off to Joyce to introduce some of what the teams have worked on in this phase, and then get started with the presentation.
Okay, great. Thank you, Martha. So as Martha mentioned, the 10 teams that initially started off were whittled down to 4. So we're looking today at the 4 finalist teams. Over the last couple of weeks, they have been working pretty diligently with Chris Romano and myself, as well as Philip Barr, who has come in to help advise the students, and Mark Bajorek, who's a structural engineer. So all of the students have had very close, let's say, working sessions in terms of developing their structural aspects and developing bee habitation aspects. So the students today will be giving 15-minute PowerPoint presentations. The only requirements that they were given was to produce plan, section, and model at 1 inch is equal to a foot, and so you'll see some of the models around, and a site plan, as well as a perspective rendering. But many of the students produced far larger models and other forms of documentation, so they'll talk about their projects more specifically. I also wanted to say, in addition to Philip and Mark Bajorek and Chris, Alec Poklinkowski has also been helping us. He's a student in our department and also knows a lot about bees, so he's been helping out with the advisory sessions as well. Okay, should we get started? Okay, so the first team to present will be Team 1.
So the only change is you're going to have to use the mouse or the arrow to advance slides. That's okay. And then if you need a laser pointer, we'll use this instead. Okay. And then let me know if anything doesn't work. I'll help you out. Okay. So 15 minutes from. Okay.
Hi, my name is Joyce Swerdlin.
My name is Daneille Krug.
Alex Galante.
Kim Dai. Where's the clicking thing? Okay. Okay, so our project is Reciprocal dwelling. This is the site from the new location, and we saw the vast opening space as an opportunity to engage this open space more with the silos as well as with the bees. This is the site right now. You can see, where's the laser pointer? Oh, okay, sorry. You can see that the new location is framed by these silos, and we wanted to engage a conversation between the two. This is the current location of the bees. It's within this building on a wall within a window, and we like the enclosure of the space and the relationship that the audience has with the bees through this window and this viewing port. So we're interested in relocating the current experience of the beehive through the creation of a protected space for bee inhabitation where humans are able to visually interact in a contemplative environment. This is our new proposed location for the bees. We placed it in this open space and hoping to create more engagement and activity to the open field that is currently there. We see this space as an opportunity for new paths that might connect the current approach to the site, which is these highways right now. And then,
in doing research for the project, we found that bees are very strategic and intelligent about their placement of their hive. So we wanted to reflect that and try and match the intellect, if at all possible. So at first, we placed the beehive in the northern portion of the structure. This is to shield it from the harsh summer sun and hopefully keep the space regularly temperatured. As you can see, the summer sun will reach the beehive. So the beehive is located right here, and the summer sun will come down at a steep angle. This is at the highest point of the summer, so. And then in the winter winds, we use apertures to attempt to bring sunlight in and heat the space by radiant heating. To accurately account for solar relationships, the orientation of the project was tested in Ecotech to explore relationships between sun, shadow, and the project itself. So you can see this is the winter and summer solstices played out. In the summer, the sun only enters the northern hemisphere for the last few hours and earliest hours of the morning, so that wasn't a concern. And in the winter, you can see the large aperture in the southern part is allowing morning sunlight to enter the space to warm the bees. Another factor was the winter winds. We wanted to shield these cold winds from reaching the hive, so a large blockage was placed in the structure. So the southwestern corner of the structure is less porous and less blocking winter winds. Summer winds, we allow for apertures to accept summer breezes, allow for ventilation and natural cooling. And as for the bee entry, we placed it in a place where there would be a calm spot in the wind, so the leeward side of the structure. And this was just so the bees would have easy access.
Okay, just as the height allows for the bees to be away from the calm spot with the winds. We also raised it up so that it would be elevated from the predators that could possibly be in contact with them. So it's elevated, and also the entrance is kind of slanted down and away from any rain that would be dripping inside. And then we also, just as we allowed height to protect the bees, we also have varied heights of spaces to account for children and adults of any size. So that's showing the different height ranges. And then these are some sections showing the different openings. Here we see the different views that are pieced together through these openings that were shown in the section. So we wanted to create a framework through these openings that would frame the landscape together. So we kind of pieced together this landscape of all of the grain elevators through these views. So now you can see how you can start to piece together this landscape through these openings, and then we place the beehive right in the middle of that, so you can kind of see it in combination with the exterior and the interior of the beehive.
And so also in this image, you can start to see a relationship developing between the enclosed space and the texture of that enclosed space and that of the grain elevators, the frames which it views, or the views which it frames. And so you kind of see this texture relationship begin to develop between these two. And so with the grain elevators, from a distance, we see kind of these rippled vaults, kind of vertical vaulting from the elevators, but when you approach them up close, you see this very smooth, kind of austere surface. And in our project, from a distance, it appears as this smooth kind of object in the field, and as you approach it, due to the construction techniques, it actually forms these pillows, and so the same rippling effect is seen within our project. And so once you're inside the project, you're up close to the texture, you begin to see that kind of mimicking and reciprocal relationship between the project itself and the site in which it is placed. And again, if you are close to the grain elevators, you kind of view these similar textures with this smoothness. So they kind of have this relationship that kind of speaks to one another in this through the construction techniques. And just kind of reiterating this idea of this texture. And so to create this soft pillowing effect, we have chosen to use a fabric formwork for our project. This is a precedent called Real Estate Project in the UK. And they use this fabric formwork, as you can see, to create these really soft textures on the surfaces of this project. And to structure it, we looked to Nishizawa, who created the Tashima Art Museum, in which he used a terraform to create the form of the object, and then excavated the earth within it using reinforced concrete to create this enclosure. And so in our project, we're using this similar formwork where we create an earth mound. It's tamped down in several layers, and then over that, we are proposing to cast a canvas bag, basically, that we will then fill with concrete. You can kind of see portions of that in our model, how the canvas will begin to form the actual structure. And so this is just kind of a process of how we built our model. And so in this process, you can kind of see how we are using this similar technique of creating the soil mound, tamping it down to build up to the form that we are trying to engage in. And we use different techniques to make sure that this form was what we are interested in and the right shape. And then you can see how the canvas would literally just be draped over. And inside of that is a wire mesh with rebar around the openings to support the openings. And then it would be filled with concrete to create this kind of pillowed effect that is seen. And then once this is done, the process is to excavate the dirt from inside, and you're left with this kind of sculptural object in the field from this construction. And so once again, kind of just reiterating this, the way that this form will be able to be created and the foundation on which it will sit. And so, and then this is the roof line. Entry spaces, there's a lot of points where different people and air that we talked about will be able to enter and circulate through the building. And so this kind of shows the relationship with the human. And our tribute to Rick. And so this is how the object would sit in the field in relation to the site, the pillowing effect, the ripples, and the contemplative space to view the bees. Thank you. Posed to the beekeeper as well, and the response that we got was that the bees will inhabit any surface. So as long as it is the right climate conditions, the bee will be able to adapt to anything. The wax that they create is very adherent, and so it will stick to any surface, really. Even the glass. In the current situation that they're in, they're actually attached both to plywood and glass, and so that kind of shows how they can adapt to these different surfaces.
A plexiglass plane or a pane that would sit in and trying to replicate the current situation so that you have the bees set upon something, they're enclosed. It's like offers protection for both the bee and the human while allowing them to be visually connected.
So the two surfaces that are against are concrete and glass.
It would not be glass, it would be some sort of plastic, yeah.
And they enter from the outside.
Right. So that creates that separation between the humans and the bees in that sense. I think the idea of the overall project is that it will become kind of a public park. That's the goal of the overall site. And so this will be kind of a folly in that site that will you'll see in afar off, and then you'll approach it along a pathway that will be created through this park system. And so in that sense, it will stand kind of as a folly, which will be approached and viewed from different angles in different ways. What's that? I'm sorry? Yes.
I just wonder how in the time until that park is actually functioning, if there would be other locations closer to other existing nodes there that would make it more easy to make.
I think what we'd like to do, though, is to start to activate the entire site. And so by placing this further in the distance in the field, it will draw people to it, and so it will begin to activate the rest of the space around it, instead of just placing it right on the edge of the site where it might be more accessible, but then the rest of the site is kind of left to waste. So I think we want to we want to see the entirety of the site to begin to be activated by visitors.
It would be interesting then to see how it's on the road, and like what it means exactly in there. It's not about like existing trees or how it's working. And then the other comment regarding the designing of the project, I think it's very interesting the technique that you're using and how it's linking itself to the site too. But I think you're missing an opportunity when you cite the project here by using the ground flat, when you're actually already totally altering it in order to give the form, and then you can model that interior space by modeling the ground floor. What you can excavate farther in parts and then potentially generating some seating or like the object right now is using the landscape in order to actually sit on it, but then you're not using the possibility of modeling that landscape.
And in previous iterations, we were considering parts of the top of the cast to become furniture on the inside, and that is something that we would be interested in returning to and developing the ground plane of that again. Because as demonstrated by one of our precedents, that it is a very effective way of sculpting the ground too.
The interior, the way you render it is you just have a continuous, the grass just continues beneath the structure. Is that how you envision it? Yes. So the grass is solid. And so the paths, well, that's kind of vision in the future. The paths are not part of the project right now, right?
Yes, I believe so. You guys want to speak about that? Right, yeah, the paths are, they would just, in our vision, it's just part of the landscape that they would kind of encircle, and then you would have to kind of leave to approach.
But what I'm asking is that you're not designing the paths.
Correct, correct. Yes, no, we're not designing the paths.
Are the bees are in residence all year?
Yes.
They don't leave when they come out?
With the dog.
So your comments about the sun in the winter are interesting, but I'm holding your model here, which is very cold, right? And I make you think about the thermal mass of concrete and how you, during the winter months, is the sun always going to compensate for the cold temperature? Like, is it going to be really cold in this structure?
I believe that thermal mass will help, and the porosity will help, but also the bees have their own tactics to fight the winter, and so it's we're kind of just letting them do their thing.
What do they do?
In the winter, we saw them in their current location. They ball up and they kind of make a ball within the hive, and they shiver to protect the queen bee. So that's how they generate the corn. Right.
Okay, let's get it.
I think that was a comment overall from the beekeeper, though, that the environment that we create needs to be sheltering.
Yeah.
But overall, the bees they're very confident, they're very extremely intelligent, and so they're able to adapt to these different situations. And we provide the basis for them to be able to survive on their own.
And how do they enter from the outside?
There's holes drilled in the concrete, 1 3/4 inch, so that they can enter from the outside. That's located higher than predators. The skunks that might try to get over that.
But why are the holes like that instead of perpendicular to the surface?
That is so that rainwater wouldn't enter into the hive space.
So it doesn't have to do with feet.
Yeah, well, to protect the bees, though.
Okay, so there's no entry or exit from here. You only.
Correct. It's only on the opposite side that the humans would occupy.
Would you consider providing more than one spot? More than one?
We had considered that, and that was a question that we brought to the beekeeper. There was a comment that we could possibly fit 2 colonies within this space, but with the way that we were situating them within our project right now, they would have to be too close to each other, and they would end up fighting each other. So we didn't want that to happen, so we decided to keep it to a singular colony within the project.
So if this were to multiply, picking up on your own comments, then you would recommend building multiple structures across the site, right? Each with a hive.
Right, that could
rather
be.
than multiple hives within the same.
Yeah.
Like how to make, so going back to that question about how do you make more of an impact on this very big site, then a projection in the future might be, okay, we start with one colony and then it begins to multiply.
Right, that could be a possible future.
Which could have an impact then on topography at a larger scale.
They might, but that was one thing that was kind of put off. We are only interested in creating a habitable place for the bees to live. We're not interested in managing them. I think the beekeeper kind of stated that. And so we're only trying to provide a place for them to live. There's an issue with the bees right now called colony collapse disorder, in which the population of bees is greatly decreasing. And so there's a great need just for habitable space for bees to live. And so that's kind of the goal of this project.
And also, I think they see themselves in certain plants. Do you see that potentially maybe in the landscaping also of that area, it is going to be encouraged? Are you aware which plants are they feeding themselves with?
I don't think we know exactly which plants they feed on, but the colony that currently exists is enormous, and it's been surviving for, I think, 5 or so years. And so we believe that the colony will be able to maintain its survival in the new location.
Yes, but I mean, it's interesting, the comments about how do you handle the landscape. And could you do things that would further things that might support the bees on the site? You think about buying some seed and putting it in the ground and encouraging the plant habitat that would support them on the site. That would be a good thing in terms of the landscape, which is, as you mentioned, pretty big, wide open, and rustling.
So we have time for maybe 1 or 2 more questions. So if there are kind of key unresolved issues that you see or questions that have on the team is here, please ask.
I have one more question. Is the dimensions of the current space for the bees, does that allow for growth? How big is it in relation to the current hive, and does it allow for growth, and how much growth?
The dimensions of the proposed space are, I would say, about equal to what they have now. And so it doesn't allow for growth just now, but we had considered other ways of just creating a wider area for them to populate. And just on that note, we were aware that this was one of the larger colonies that I had ever seen. And so that's it.
And also in their current location, they are only occupying about 1/3 to a half of the space that they have. And so when they would be relocated, the colony would most likely shrink a little bit. And so then it would take some time for it to regrow to that size again. So there is time for that growth.
But the space is measured, it's dimensioned off of the current hive, not the current window that allows for it.
Off the current window.
Right now, there's a roof.
Yes, it's off the, yes, there is a roof.
So it's based off of the window dimension?
Window, correct.
From the biological point of view, they save all the students from the biology. The bees design is not going to have impact on that. That's the next process is going to occur, and will be managed appropriately by the bees themselves. So, just to kind of clarify that, I don't know what the so far down on the survival scale. Yeah, that too, everything.
Hello, everybody. My name is Courtney. This is Kyle, Lisa, Dan, and Scott. I'm going to introduce our basic concept and talk about our siting and general design of our hives, and then Kyle and Scott are going to discuss our construction techniques. Dan will go over our structure, and Lisa will talk about how we're actually accommodating the bees. So Rick is footing the bill for this, but he's our actual client. So this is just a picture of their current state and our current site. So HIVE City, which includes Marine A, Train Elevator, and several others. But in Rick's initial presentation, an introduction of the competition, he was saying how he's really hoping that this can be a project that kicks off the regeneration of this property, and how it can be both an economic and a natural redevelopment of the site. So he has his company down there, Rigidized Metals, but there are other building and construction companies, or construction material companies at the site as well. So we're trying to incorporate that nexus into our design and symbolizing the redevelopment of the site. So this is the general location of our views. Like it was brought up before, we're not 100% sure about the placement. It's going to be part of a larger landscaping plan. But in general, with the new entry to the site, we want to have a sweeping path that comes through, and as you work your way through the site, that's an existing railway bed, which the path would follow along, and as you come to the beehive, you would turn back up towards Child Street. And in this our more detailed site plan, it shows the direction of the wind hitting our structure. We decided to base our plan off of the hexagon with the honeycomb. And we have two entrances for special human, for human entry. And then there's another side which mimics the existing conditions that the bees have, which is like a northeastern side. Which is full for the bees, and then beekeeper access, which we'll see in a second. So our design is a tower, which is kind of a typical iconic thing, but in any sort of civilization, they build towers. So we have a tower that it also mimics the silos themselves. So in order to get into our tower, you actually have to kind of not really fall in, but you have to come down a little bit to keep it. And this is tile inside one of the silos in Marine A. So it mimics that, and then our hive is actually placed above you, so you look up at it like you would be looking up a silo. And our general materiality is the structure would be steel, and then panels that actually enclose the hive are metal and glass, and then the actual box or the bee cab where the hive is located would be wood for a little bit better thermal mass. So in this second section, you can see that is the hive in its viewing position. This first one on the left is where the beekeeper would be able to lower the hive in order to access it for maintenance and general overall health. Here's maintenance, and there's a rope. Well, there's a pulley system in order for someone to be able to lower the hive, and then there's a door that opens up where it would be large enough for someone to stick their arm in and be able, the depth of the beehive is small enough where you could stick your arm in and actually be able to reach all the way across. And then our general plans that we have here, again, it's a hexagon shape plan, and at 3 feet cut, you can see just columns that hold up the tower, and where there is many panels, that's where the various entry points are. And then here is at 6 feet where you can see the cap start to appear. There is a diagonal cut through it. Initially we had a flat bottom to it, but with this cut you're able to see more of the hive at one time. And then at 9 feet you can see the entirety of the bee cab, which is also, it's an inset hexagon then. So the bee cab is also a hexagon with a diagonal cut for greater viewing, and as Courtney mentioned, it slides up and down. There's 3 holes for the bees to enter their each an inch, and then in our outer skin, we have the panels, parts of them open up and allow the bees to enter in the same orientation. Here we have an access door for the beekeeper to get in and clean or maintain the hive whenever he needs, and all he has to do is lower it. The material this is fly glue, it's 1 1/4 inch thick, that will protect the bees and give them warmth, and we also have the double skin, which will add more protection. And the bottom left, third, there. So here's the access door open, and then when it's sealed shut. So that's just a quick render started with our moving large. Yeah. And there's so that's just a render of the guy looking up. Here's children, so if a group of kids want to come, you can lower the hive and allow them to get a closer look and better access for educational purposes. And this is the beekeeper, who's right there, actually cleaning the hive. Here's some model photographs, so you can see the end tree for the bees when we open our panels. It also looks at how it breathes. And then here you can see the entrances, which are about 4.5 feet tall. Okay.
That's okay. So we basically looked at fabricating a tower out of just standard steel sections. We had some earlier tower designs that had columns, and then we wanted to get away from columns and open the corners up. So we kind of started to come up with this kind of structure where the column is kind of staggered. We also, this was an original size and column which we kind of, learned from the engineer we could make smaller. So we basically worked out a system with both 1.5 inch steel tube and then 1.5 inch angle and 3/4 angle to get the 30-degree, well, the 60-degree corners we need in both plan and section. And here you can see most of the way it goes together. The drawings on the left are actually not quite right, because if you look at this, these are angles now instead of that piece that's set in the back. And then this is showing basically how the panels would be inset into the structure. The way the panels are here, and so it's just showing that's on both sides. And then Dan, you might want to talk about this.
Yeah, I'll cover more about the foundation in a bit. This is just sort of a construction diagram for the vault footing the foundation. So basically what we have is the loads being distributed through a structural web, and there's 3 tension rings or compression rings within there, and they each have a dual purpose. The 2 ones on the bottom are for a seal, so the bees, when it's moving, they can't get to the people at the viewing area beneath. And then the top one is the actual rig for the cap itself. So those are their general locations, and they'll provide stability for the structure. So I did some quick wind diagrams and calculations in order to figure out what we would need for the foundation. There's 2 options for that. We have vault footing, which is shown here. The actual number was 10.8 kip feet for the overturning due to the wind, and the calculation also takes into account the rough shape. It's a hexagonal solid tower structure. And here's the other option we had in mind was a buried slab, and this also goes through the calculations for the overturning.
So this is just a quick animation showing the process of actually constructing the thing. It's going a little faster than I could speak, but you can see what's going on.
There was some talk about like wood, metal, and glass panels, but I think
the detail we worked out right now is glass and metal panels, but then the cab itself is wood, so you still have that.
Here, this is for the bees that enter and for the towers. Yeah. Oh, no, there's a couple, but we're gonna add more at lower points, but we have to just work out the kind of compression ring a little more because it, right, so.
What's the, you said it's like 9 feet tall, so it's about
no,
3 feet diameter?
It's 16.
Okay, so what's the?
It's 4 feet.
4 feet.
And this is without tray.
And in the bee cab.
Is that your terminology? Or is that a?
What are the bees fixed to the glass?
It would be fixed on the top.
So are they hanging?
They're hanging.
Okay. So this might be a question for Philip, but currently the bees are sandwiched and fixed to both the bladder and the glass, right? So, so when the bees are moved, they don't need to be fixed to two things again. They can be.
No, they will. The normal orientation is hanging.
Okay.
The normal beehive. You know.
And this can go from fixed to two services to hanging.
Yeah.
Could be a different group of bees to do this.
And row UV.
You mentioned the word double skin in your presentation, but I'm not clear what you mean. Is it the wood becomes the second skin?
Yeah.
Okay,
So-
but otherwise it's a single skin.
Right, the double skin's only for the bees.
Okay.
So the bees get a double skin, but the people only get one skin.
And can anyone raise and lower?
No.
Okay, just
him.
Whoever is here.
So.
So
is the mechanism inside the tower or outside?
It's inside, so the cab only sits basically in the middle of the tower, and then our mechanism is our entire mechanism on the upper part of the tower.
Something has to come down and let it out for the beekeeper, right?
We have a rope for the beekeeper, and we'll have a little block.
Can you not have the additional compression ranges? That seems like overstructured.
We could. Currently, well, we definitely need the top one. We need something that holds the entire net up.
Why? You've got a hexagon at the top of the tower.
Well, they need to, I guess we wouldn't technically, the bottom ones are just, the bottom ones, there has to be something on top that structures it.
We could bring
it in
at angles.
You could frame a lid.
Yeah.
Right. That will change for
It just seems like you've already got a lot of steel, and if you think about your compression rate, because you have a fully welded structure, is that right?
Yeah.
Okay, so instead of your compression rate being like this, your compression rate is like this. Going around. So it's not that you don't have it, it's just that it's a bit more complicated, it's more. But it just seems to me like you could eliminate it.
The other consideration though is steel.
We worked it in, we wanted to have, kind of from day one, we wanted to have a seal, so it's kind of this area where only the bees can get in, so we don't want, like, as you move the cap, we don't want them to be able to, like, slip out. So we're going to have a gasket around, so there would be this distinct separation between the bees and people. So then we worked in the compression ring with that. I mean, we can rework the seal.
Do those requirements. You didn't want to get anywhere near
That's my fault. Double the compression rates.
What is the geometrical logic that you're applying to these panels? That there starts to be some variation, I see, for the open, but then there's like chopped, no? Like, I mean, is it, is there some sort of fractal situation here where you have that example say inside the actual beehive, and then you're reproducing that, and his bee line is also an example. But I'm right now it feels arbitrary the way things are opening or starting to happen in regards to this geometry. Like the fact that this is chopped, how many of these is one, what is running these decisions?
have a lot of materials, and you have all materials both flat and folded panels. So, and I would say it would be good to do an analysis with a view to perhaps trying to simplify that. At the moment, I don't know how you decide whether something's metal or wood or glass. And then you would say, okay, how can we simplify that? Right, to do a folded panel in glass, or what are you talking about using glass or plastic? But you could say that's more complicated than doing a folded panel in metal. Because folded panel in metal we know that we can easily do without any joints. Thinking through that a little bit to try to simplify it, give yourselves some time.
And I think that it has to be more interesting also with this operation happen because it's a necessarily a three-dimensional structure, but you are using it sometimes just like a pattern, a black pattern on the surface. So I think the more that you actually understand after the exam idea, like the executed situation, like the geometry of the thing, and there's certain things that could be realized. Well, and I think it's very interesting the power conditions within the site, because probably now one isolated object within the site and it's reflected in the operation. So it would be, it's kind of like a complex there. So it would be, it would have an impact. How tall is it? 16 feet.
It's like 16 and a half.
So if you made some openings in it, you said it wasn't completely flat, wouldn't it reduce your window even after?
Good, but then you might kind of pocketing. Typically, yeah, I suppose it would.
Have you done any analysis about the environmental performance of the tower? Like moving the grass in the tower, or the way pieces would be hard for, or not? I mean, it may help you also in terms of discussion on the planning. There may be places where you want to have play, there may be other places where you don't want to have play.
Yeah, we had discussed in the upper third or so of the tower having like the panels removed or selectively removed to allow wind to come through. But we need to kind of reassess that.
The diagonal slice on both the cap that's picked up on the form,
yeah.
at the top, why is the geometry different? This is just a clean slice. Here the geometry starts to bend.
Playing it with that model, that was just, that's actually, model's different than the drawings. So I built a model. I mean, the model's sort of a working model where I was just sort of playing with the surface and seeing what it could, do.
So this is, I think this is something that we need to it's a special condition. I don't know why it's been created rather than just slicing. And so, in a way, it's a ringhold that I think you'd want to.
These are these kind of unclear situations that I was talking about, because there's like some operations like manner, but then it's emphasizing of the cells. I think there needs to be a cohesive approach for the geometry and the patterns. Right now, something here, something there.
So you're saying that only the beekeeper would be able to lower the ladder?
Well, anyone else who has access to that key.
So people who are just walking on the site?
Can't lower it.
So how far above the cliff?
It's like 6.5 feet in the air. So it's like really close to you.
So yeah, if they were standing in it, like their head would be here, they'd be looking on.
When it's in its raised position.
That's in its raised position.
So it's always visible, whether the beekeeper's there or not.
Right.
And it's only for maintenance.
And if the class wants to come, because we put them on the children, if the beekeeper's there, we just give permission.
So this is a kind of cross-group question. You're allowing for maintenance access on the part of the beekeeper. In the first group, you mentioned that not at all. What is the beekeeper?
I don't think,
The first group did have a maintenance strategy.
I'm hoping now with your
it is important that have some kind of access to HIVE.
And just out of ignorance, what do you do when you get hacked? You open it up, and well, we no, in a typical scenario, you know, you don't want to harvest honey, you want to manage and control for diseases. But as I spoke to the groups this past week, the presence in the Northeast of certain types of mites, fungus, and viruses necessitate being able to get in there in case of an infection that kills the colony. You need to be able to basically sanitize the space before you introduce new bees, before new bees come in and introduce, in order to stop the spread of these diseases. So what, you spray something or you? Yeah, in a catastrophic failure type thing with an infection of the hive, and they die, you just want to go in, clear all the comb out, you get rid of it, and bleach it out, clean it, whatever you need to do, and then start again.
And last question we have again, Trevor, maybe one or two more questions before we move on.
What do you think is I think there's a very strong decision where you have the hive handling, it's kind of like these old watches, and but then some of the panels are open. Is that for sunlight? It's kind of like you have these jewels that is pendant inside, and it's protected by this outer. So what is your ambition? That is seen from the far, this inner thing, or that is covered? Why are the opaque panels? What is the idea?
Well, we have the glass panels on there to allow actual sunlight to come in, so when you as a person are in there, you can actually see the bees, see what's going on. But the actual location of what you were pointing to before, like the actual exact location of what's what, I think it could work out a little bit better. And you'll be able to see the gap.
Yeah, like that is already opaque. You can be opaque panels outside. That's why that there are opaque these
Have you thought about using all transparent?
For example, I'm thinking, what is the strategy? I don't know if the strategy is to look at that beehive suspended in the middle from the far, and then there's this thing that protects it, and because the beehive is already opaque, maybe it's okay for the tower to be replaced, and everybody to actually look at this thing. So the tower fits up, I'm just asking for your intention to see it's a bit ambiguous right now, because it's partially covered. Like these opaque panels, I don't know if they're for shading, but yeah, in fact, the object, if they're needed for shading from the beehive itself, or if it's an aesthetic decision, why
What is your view?
We partially wanted you to be able to see like some kind of list of beehive in there, but also at one point we had not more glass, but we didn't want it to basically like bees inside there. We didn't want kind of effect, but our initial idea also was to try to have.
I think for time reasons we're gonna have to cut it. We're getting a little behind. I'm sorry. Sorry to cut the conversation.
I think we still need to do more studies with that.
So we're group 6, and I'm Scott Archambault.
I'm Anna Auestad.
And I'm Joseph Sevene. You know, it's funny, you charrette on these things, and then you stand up here and you try to remember what you did. So that's what we're going to do now. So our project starts with the existing beehive. Our project starts with the existing beehive, and what you're looking at is an image of a beehive in a window in a room. The bees have their own entrance. They enter from outside of the building, and humans also have their own entrance. Presumably, the bees are finding food in the field outside of the building. Can we go on? Oh, this way. Okay. So basically our scheme tries to repeat the existing condition to celebrate it and preserve it. You see that on this side of this section perspective, there's a human door. So people go in here. The space in here is for viewing the beehive, and the beehive is over here. The connection between humans and the bees are the plants on top, right? So the plants provide food and they provide, sort of a thing for humans to delight in. The building, or the very modest building, is built out of reused 2x4s. Our group considered the reused 2x4s to be sort of an indigenous material in Buffalo. There's houses are being demolished. We talked to Buffalo Reuse, and we realized that we can actually buy that material for 14 cents a foot, which gives us a basic material cost of about $500 for the wood structure. Is there anything else you guys want to say about that? So we'll just walk you through our the way we think that we're going to be able to implement this on the site. Starting with the foundation plan, our structural engineer tells us that our building is solid enough and simple enough that it can basically sit on just concrete blocks out in the landscape. There's no extensive foundation work. There's no extensive earthwork. Just blocks on the ground. The building sits on top of it.
The conceptual basis for that decision as well was to maintain the autonomy of the actual object of the building from the ground condition of the site. We kind of decided that competing in both material, precision, and scale of the grain elevators themselves was the wrong way to go with this. We decided that we wanted to kind of have this autonomous wooden condition that was sitting up, elevated from the ground.
Okay, so the floor framing plan is just a wooden 2x6 deck, just like your house has, or maybe your deck in the backyard has. To the outside of the deck is fastened a steel angle. It's bolted into the wood deck. And on top of that, oh my goodness, these are out of order. Oh, I'm sorry. Okay, so on top of that sit the 2x4s and 2x6s. Those are bolted in to the angle down below and held in tension. In the section, again, you see this deck down below. The 2x4s are just stacked up on that deck, and they're just bolted into place. The bees live in this little window over here. That's our new beehive. It's installed in the opening. That can be removed for inspection, or if there's any problem with the bees. Oh, I'm going back. I'm sorry. I'm the one that's going backwards here. Again, in the ceiling, oculus, the thing is open to love. And in the roof plan, there are indigenous plants, as we mentioned, growing in these boxes. The west elevation, there's small holes, and those holes are loaded up with sticks for other insects to inhabit the building. My teammate Scott said something really nice about those. He said that nature thrives on competition. And so rather than being a house that's only for bees and only for people, we've tried to pose the question that, other species will live here in all of the projects, and why not offer a habitat for those as well. The east elevation simply describes the construction. The south elevation shows the human door. and also hints at what is to come inside. And the north elevation is the entrance for the bees. So that panel is just situated in the building, and these little holes are the bee doors. So again, the project is based on the experience of just going into this thing and observing the bees. It's exactly what we've started out with. It's a window in a room where people can quietly observe bees, hopefully not disturb them, but just enjoy their company for a few moments. Thank you.
It's just over 10 by 10. It's a 10 by 10 cube. And the floor to ceiling height on the inside is, I think it's 8.5 feet. And then the roof garden sort of, or it's not really a roof garden, but it's recessed below so that the plants kind of just flourish on the top.
Did you talk about the slide?
Its autonomy from the ground condition can really be placed anywhere in that field.
About the siting, there are other architects that are working with brick and cell city. They actually specify the site, and so the students are not actually all just put the models in that location to try to kind of make sense of the environment around. So they weren't choosing the site.
To go a little further with that, though, we try to propose, in terms of siting, we try to propose a building that a lot of people would be able to build on their own, perhaps in their own backyard. So in the same way that this building, would be sited in the field at Silo City, we think that the light construction, the way it touches the ground lightly, can actually be placed in a lot of other places, inexpensively and easily. Two farms might want to be behind the Buffalo Botanic Gardens, might also want to be here. So hopefully it'll be sited in more than one.
So does it matter what the planting on the roof is?
Planting on the roof, in this view, we're actually showing plants that are native to the site. We've actually gathered the plants from the ground and just put them on the garden. We've also constructed this in a way that the roof garden and the building itself are separate things. So the roof garden basically sits in large flower pots. And in that way, because this is a little bit of we're at a time crunch, right? We're going to move to these in June. That means that all of these things that need to happen in the next 3 months. So in terms of phasing the construction, we propose that one of the first things to be built would be flower boxes, and the plants can have a chance to start when the building is done. All of that is just set right up on top.
Why do you think that's not
the garden? Well, bees use nectar to make honey, which they eat, and they also use the nectar to make the wax from which they build their hives. Okay, and different flowers produce nectar at different times of the year. So the way that the thing to provide for bees to encourage their survival is food from plants that are brought at different times of year. So we thought to just provide that for them. So it gives us something to help them feel welcome. But I think the plants are, the plants are also the connection between the bees and humans. I mean, we are dependent on bees for pollination, right? And we pick the plants, and we realize that we eat the give that to us. So the flowers are, sort of a social connection between humans and the bees.
Well, you can tell just by the way we're talking about it, we have an incredibly romantic view. but it's important. That's kind of how we've been doing it.
The architecture celebrates that connection.
Attempts to.
What's the roof again, or how did you make that? What's the technical?
The roof is 2x4s. Thank you. The roof is 2x4s turned out end. Yeah. And they're spaced right next to each other. Like that.
Mm-hmm. And so is the floor. Right.
Well, the floor is on the frame.
Right. But the roof is also a framing. Yeah. The framing would be the same condition.
So it looks like the 2x4s are made that way, not this way.
Right.
Do it that way.
Do it the second.
I'll work through this section, and that you're exactly right. The bottom is just something like pressure-treated plywood, right, with the angles bolted into it. The roof package is these members right here, I would say are 2x4s that are glued and screwed together. So we're making a beam out of the same material that the walls and the floor are made of. And there is the deck.
It's 2x4s.
What is it that keeps this from doing this?
Let's go to a plan. You see in the plan, there's these two solid walls on the north-south axis. These walls offer shear resistance for the north and south walls, and the angle is continuous around the building, so there's two hoops around the building, and that provides the shear resistance for the building.
And also the tie that you see emerging from the top is the thing that ties all the 2x4s together. They're rocks. Right. And we've expressed that on the top as
well. So the floor is the plywood sheets.
The floor is 2x4s laid.
It is 2x4s. Yeah. Okay. I have trouble seeing that. I saw the rendering.
Right.
The section.
So in this section, they're going the other way.
For some reason, something makes me want to say, can you do the whole thing out of 2x4s? Get rid of everything else. That's like the 2x6s, plywood, and this and that, and just say, okay, we're going to do this all using recycled 2x4s. And I think you can do it. You have an idea about a roof structure. I don't know how you can use that at floor level as well, for example. But then, why have just a plywood deck? So, and I suppose it's just because of the simplicity of the idea. And say, how can we be really resourceful with a really simple, standard, ubiquitous building material instead of making it more complicated?
I mean, you can only you can buy this stuff very little. It's very compelling in that sense. So that might be something that encourages what is the finish of the wood?
Well, the wood comes from buffalo reuse in it's a very rough material.
Yes.
And I would suggest sealing it on the outside. I know that's not very architectural. I do think that it would preserve the wood. And I would prefer to leave it unfinished on the inside.
What does the beekeeper say about chemical environments for bees?
Bees wouldn't just need to be in the chemical environment.
Right.
Don't see the inside of that bee can. Otherwise, bees live in the chemical environment every day, so just like we interact with the environment at various levels.
But the point is a good one. I mean, we want to provide a better environment. A low VOC environment.
So the actual cavity for the bees is plywood on one side and glass on the other, like the addition current.
unsure about the outside material.
Okay.
We've discussed. Okay, go for it.
I would propose that the outside material is cork and steel. If this develops further, what I would want to look into is how that should be insulated and how the actual design of the bee hive itself can provide ventilation. Bees can close up holes for ventilation and open them up in the summer. I think the design of the actual hive is very important. Basically, it is a panel on the outside and a panel of glass on the inside, and the wax is spanning that distance, just like it is now. But in moving the design forward, I think the design of that element is there's a lot of questions to ask and answer.
And it's removable?
Yes.
On the house, on just the outside, or?
Completely removable.
Yeah, the whole system.
How do you think about like weathering and drainage for the whole project?
The roof needs drainage.
On the inside.
It's a question.
I'm suggesting like
I mean,
to start to think about.
I think one option, I'm glad I came up. One option is to try to weatherproof the outside. Another option is to just let it drain through. That's something
we don't have a door, we don't have glass on the skylight, so that seems to be an option for the appliances. Does just allow the drainage to go right through.
Okay, so Scott, I have a question. How did you decide on the 10 by 10 dimension?
The dimension.
Anything. I mean, you could do it like looking into basically the dimensions that started off at the beginning of the project, and also standard construction. You get 10-foot 2x4s.
Okay, so you feel that you have a good supply? Or just that's what I was wondering, whether you would have much easier time doing it if you said it's 8 feet, then you would have a much bigger material supply?
Right. It's yes.
So you say just pull it down a bit.
Right.
Because then you don't have the special condition. You're not looking for X number of linear feet on a special condition.
Yeah. The wood from Buffalo reuse seem to have plenty of supply of reusable material. So yeah. So what's that?
They're not critical lengths currently.
Right.
That's all.
Right.
The joint at the corner is a finger?
Yeah. Yeah, it's like exactly.
So actually it's a 10-foot long 2x4, you'd be looking at 10-foot.
It's a little bit over. It's a little bit over 10 feet. Yeah.
Jaw.
Yeah. Yeah. The ring of the foundation ring is 10 feet by 10 feet, so it actually overhangs a little bit off of that angle.
Do you imagine this structure just does over time rot?
What's that?
Does the structure just over time rot? That's the plan?
Yeah, I mean, it's like I said.
No, that is not.
Good question.
Again, the reason that we did not follow through with the 2x6 structure everywhere, and we made the decision to sort of step back from the sort of architecture and say, okay, well, this thing's going to be sitting in the field, it's going to be wet all the time. Let's think about making the deck 2x6 pressure treated wood, and maybe that'll help the longevity. I see someone shaking their head, but it brings up a question about longevity. It's not intended to sit in a rock field. It's put it on the ground to ventilate and to be able to dry out. Why are you smiling?
It's gonna rot. Yeah, the whole idea of, this is a discussion for another time, but like the whole idea of the kind of connection with the plants, the bees, and the people, this is like something that could easily be rebuilt anytime for a very low cost. So it rotting is not, and it's almost part of the actual cycle of the interaction with the plants.
Yeah, I think rather than instead of saying, oh, It's got to be sealed. It's got to be preserved and treated. It's got to have this. It's got to have that. I would try to look at using the material in its most untreated state possible, and they can say, okay, it will disintegrate over time, and it can be made of like any, it can be easily built up again. There's an unending supply of this material locally at the moment, it seems, and so I don't think that's necessarily a bad thing.
Right.
You know, it's like the Japanese temples.
Right.
You build two of them.
Yeah.
But you have
every 20 years.
You have one and then you build it up again. But somehow getting it to respond to the cyclical nature.
I mean, we're using this material at the end of its useful nature anyway, because it's reused material anyway. And yeah, to give it another life and then get it to the end.
What about the bees then?
I mean, then the same kind of transplanting, the panels themselves are removable that can be relocated. I mean, that's obviously something to discuss with you.
How long do they stay?
Well, I think with Rick, you know, we talked about the first time I saw the beehive, it's probably not the same hive that originally started building it. At times they may have died off and new had come in. Maybe it is the same, but what does happen in the natural world is that if a colony does naturally, without disease, collapse, which does happen outside the colony collapse disorder and all that's going on now. Oftentimes a new colony will go in and have space that's already pre-existing, they don't have to build as much, take advantage of the prior hive that already exists. I feel like what's being overlooked here is the bees. If you build, you know, create the opportunity to build, for them to build with you, and then have to transplant them again, you know, remove the comb, it just seems like, I can see the logic sort of behind the temporalness of it. It's going to go away, you know, it'll come back into the earth, and, you know, maybe or maybe not, the bees will be, if the bees are gone when this happens, that's good, but if they're still there and the structure begins to decay, you're risking, it seems, failure of the structure, and therefore failure of the colony outside of the colony's natural life cycle. So you're kind of interdependent, you're creating interdependence there.
But it's a natural process. It's like the same thing if the beehive was someone else, or like, I don't know, or a tree. If the tree is just by lightning, or...
Where I was trying to go with the question was, you can predict where this structure is going to come in, and you can design a relationship to that prediction. It goes back to your observation about where it drains or how it drains. It's not draining, it's got city water, it's got everything. You can kind of sort out from the way you lay this out where it fails. And you can develop intervention strategies to repair as you go without messing up the life of the bees. So it's like do it on purpose. But it is like one more step of thinking. It's really, I think, a very elegant way of thinking about everything you've done. It's like romantic and nice and sensitive. I think you just missed an opportunity as you speak of it as a natural process. Well, I'm sorry, we don't stack with this way. It's not natural, that part. But it does decay in a way that's predictable in relationship to where the water goes. So look at how it fails and think about how you would do the repair as you continue to occupy this structure.
Well, and also the case of the actual bees could be designed so that thing itself is not decaying.
Right.
It means no matter what happens with the structure, that this case stands alone distance from that, and it's not part of that process.
So this is a really good topic. I feel like we're straying from questions into answers. So we should, yeah, it's a really, really interesting topic.
Thank you.
So this is Andres, Andrew, Nate, and Serge. My name is Vincent. Nate actually has a few handouts that he can talk about.
I'm going to give just a brief general description of our project, where our inspiration came from, and some of the materials. Feel free to pass me down the name.
So the way we approached this project was how can we get inside the mind of a bee and start to envision not only what they think a city would look like, but more specifically what a city for bees from Buffalo would look like. So what this means is that the importance of the site that we were given are that these grain elevators surround the existing beehive that is there, and we all know that the grain elevators are important culturally, socially, economically to the history of Buffalo. So from the viewpoint of a designer, how can we design a structure for these beehives that responds to that and create a city for them using the same techniques that we used in the grain elevators? So this design would eventually respond to the architecture, the site, and the material of the grain elevators. Using the site, like I said, that surrounds the existing colony and the architecture of the grain elevators, we can think about formal qualities that the cylindrical shape actually contains and how we can start to produce effects in ways that the beehive will connect with visitors, the actual bees that will be living there, surrounding parts, nature, and solar patterns. So we can start to trace out, cut forms, figure out what the right geometry would be by deriving this thing from these elevators, and how this might start to react to visitors and really give people a different perspective on what this older generation of transporting grain and this newer generation of sort of transporting bees and honey. So with response to the site, we tackled a few major issues. One of them was analyzing the traffic patterns and how we can orient the sculpture to really draw visitors in from both the west side, the east side, the north side, and bring them into the park. For the winds come primarily from the west, southwest, and bees, they don't really want these harsh winter winds. They usually build their hives in small crevices where really wind doesn't affect them. So we can see how the structure actually splits the wind, and the hive would be protected on the inside layer of the project. And finally, the last thing we analyzed was how sun would react to this. In the morning, when it's a little cooler and the sun comes up to start to warm the hive, the bees would actually react to that and start their day as the sculpture starts to warm up. At midday, the sun would be at its peak, and the thermal properties of the material that we are considering using, which would be concrete in one example, would actually heat up and then release that heat slowly into the hive as the night progresses, so that there's less of a fluctuation in temperature, which is better for the bees. In the summer, when the sun is at its highest, this sculpture actually protects the bees from direct sunlight, which is another thing that we have to consider because they don't necessarily like direct sunlight all the time. And in the winter, when the sun is a little lower but it's colder out, you do want a little bit of sun to heat them up. So the fact that Chris right there would be pointing where the hives would be. Yeah, the fact that the sun is a little lower, the sun would touch the beehives. Oh yeah, it's modeled in the smaller model.
Okay, so as Vincent already suggested, one of the choices for material is concrete, and obviously you can see that concrete is all around the site, so that was one of the reasons why we chose it. Other reasons, again, thermal stability, but it also provides, it's a solid mass and provides rigidity for the bees so that it would be a solid structure that they can live in. So for structure, how this thing is built, these are sort of the order that the structure would be built in. First, we would dig into the ground and create this steel cage, which would have rebar that would come up from it. Then we would actually pour the concrete foundation, which is basically what's going to be counterbalancing this leaning arch. Then we would actually start to begin bending the rebar into the actual shape of the structure and have supporting structures such as a steel cage that would wrap around the rebar. And since the arch is symmetrical, we would do the same thing for the other side and would tie the two together. Then actually how the concrete is poured, we would actually make a framework and which would be 2x4s and 1/2 inch thick plywood or 3/8 inch thick plywood, and then we would get the completed arch as we remove the wood. So this section is kind of showing the ratios of like how large the foundation sort of would need to be in order to balance out the concrete form. Approximately about like 2/3 the weight. The foundation would probably be about 2/3 the weight of the actual arch.
So if you look at the model, that's more or less the proportions and how the center of gravity of the arch will actually shift downwards towards the foundation because the foundation is a lot heavier. So how do these actually live in the space? Where are they? Where's the enclosure, manageability, and the entry and exit?
So here we are.
That was me taking a video, like the first day visiting the site, and you can see this unique habitat that they're currently living in, and how like beautiful it is for like a person to actually see the bees, and how we wanted to keep that similar in our own structure and reflect that. So as we begin to look at an individual module of the beehive, you can see the materials are exactly reflected from the materials that were in the original window. But we want a continuous form for the bees to live in. So actually the circulation, the wood is cut out to allow for circulation across each module. And you can see the holes at the top piece that would allow for entry and exit. The rebar, we would have precast bolts, which would be cast into the concrete, and then these boxes would be bolted onto the rebar. And again, that's how it would slide into place. And then these would actually be arrayed around the arch, sort of actually flowing with the arch itself, but actually still maintaining a sort of difference between like what the structure is and where the actual bees are. And then you can see how by having like openings in the boxes, they would allow for continuous movement of the bees and one central exit and entry at the top of the arch. This is a video actually showing like the path that a bee could possibly follow.
Yeah. So another thing that's interesting here is the way that you approach this thing, and you can actually see how everything is structured on the inside. So not only would you potentially be able to see the hive, but how the circulation patterns work and where the exit actually is in the model. Again, this is just a section, again showing the continuity in the box frames and how the bees would flow through it. So, what does the completed project look like when we consider form, site, materials, and this is the final result. We would actually consider placing plants around the structure, and I think that's it.
So we started considering another route because of like the cost that concrete would take. So we started looking at steel, and concrete is like heavy and solid, and the difference between that with steel is lightweight, and then also with the steel we can incorporate the bees within the structure because we can make it hollow, and the surfaces create hollow volumes. Steel is also low cost, and it can be prefabricated. So applying the hollow nature of elevators that transfer grain to a sculpture that will house the bees, we then do the structure, which includes the foundation, framing, sheathing, insulation, and exterior cladding. And this also mimics some of the grain elevators and like its hollow nature and this transfer of grain. So we were thinking about with the steel, the transfer of honey and the circulation of bees within. So this is just a drawing showing the foundation and how we would have these steel plates that would be bolted onto the foundation. And then another thing with this is the foundation will be a lot smaller, which will also allow for smaller cost. Then there's a steel cage framing and reinforcement that's applied. And then we start applying the sheathing. And then we were thinking about the insulation within the structure, which would then be made of wood. We would have wood, which is like represented in the red, spray insulation, and then the steel itself.
And because steel actually isn't, there are more fluctuations in temperature when you use steel, we wanted to find a way of insulating this in a different method, which concrete already does because of the nature of the material.
Yeah, so like steel can gain and lose heat quickly, so we needed to find a way to insulate the space. So that would be it completed. Then these plan sections show the cutouts that would mimic the framing inside, and then these would have glass, these panels, so that you can see the bees and the bee hives forming within. So like thinking about the hive system and the manageability of the steel, we start looking at how these things would be taken off. So that there would be like these three panels that would come off, and they would be bolted in place, and then they each have glass on them so you can see the bees. And then this is again showing the circulation and how it's continuous along the arch. So we were thinking core 10 steel and how to integrate the structure with the rustic feeling of the surrounding site. So this is a render showing the core 10 steel and then the glass and the hives that will be accumulating on top of it.
Sort of how the actual bees begin to blend in with the structure itself. So whereas the concrete one actually uses different materials, and you begin to read the separation between the bees and the structure that holds them, this system is kind of, it might be a little more fluid in the way you read it as one structure that both holds the bees inside, but also holds itself up.
So basically the aim of the honey elevator is to capture the essence of the buffalo grain elevators, as well as to facilitate a safe home for bees that both the steel and concrete proposal would yield completely feasible yet different results, unique to its material and design. Thank you, James.
Well, on this model, you can see how like each box has holes in them, so they can coat the whole thing. Yeah, so one thing that would actually how Philip would get into the boxes themselves would be that there would probably be some sort of door system on the back side of the box, so that you know, open up each box and get at the leaves.
So you wouldn't have to take off the box?
Yeah, it's everything is stationary except for the removable panel at the back.
And the other option, accessibility and visibility.
Yeah, it's actually the whole. We broke it up in thirds, and it's about like a 2-foot, 3-foot panel that would come off.
Well, the steel one's actually the angle's steeper because it's lightweight. So like with the concrete one, it's higher up because of structural purposes. So like it would be like a foot lower.
Yeah, because for this one, we actually have to account for this height. Someone walks through, but the steel one, you don't have to worry about that. So we do that.
And is this the model of the steel one?
This is a concrete one, just sit on the box.
So what is your preference? If you have to choose of the two, or is there be like an addition?
Yeah, I think there's like an overall discussion about this that we've always had about which one we think is better. They both have positives and negatives, so we're not really leaning to one side. And that's really why we just had 2 proposals, because we know they're both feasible, but they both provide different effects.
In regards of the shape of the arch, so I remember in the poster it was wider. I wonder, solar-wise, when it's so thin, shadow, I doubt the performance in terms of shadow of this for the big height. In the second proposal is more protected, but in the concrete proposal with this kind of shape, I think it's a bit exposed towards the sun too much.
Well, the way we have it the way the orientation is, it gets most of the sun like when the sun's rising, but like when it's setting, like since we have it like towards the northeast, a lot of like as the sun rises, it's gonna set like here, and then this will provide like blockage.
Which is why we actually have this side as not glass blocking the sun.
And also the fact that these come straight down as opposed to following the shape of the arch. We feel that when this does cast shadows, it would be casting shadows out this way. So it'd be more difficult because of the fact that they go straight down for some actually penetrate down. And the back is also solid, so when you have this southern exposure from the sun, it wouldn't actually be, you wouldn't have a direct heat into the space because it's shaded from the rear.
It seems the second proposal is, I think, the strength of it is that you integrate the lines into the arc, whereas here they feel very much added on. The second proposal may be harder to build because your geometries are quite complicated. So each sheet of steel is going to be twisted.
Yeah.
They're ruled surfaces though, right? They're only bend in one direction. They bend in one axis. What's the strategy?
Okay, all right.
There are very good people locally who know about that.
But I think the integration of the HIVE into this one is a really positive step forward. And also you're thinking about it, it's coming down a bit, it's getting lighter. The foundations on the concrete one look enormous, right? So you've got a big hole in the ground full of lots of concrete and lots of steel. So it seems like the second alternative is a big step forward.
Can you show in the steel version how the panels work?
The removable panels.
Yeah, how you remove that.
So these would be bolted into place here. There'll probably be a pin or like a locking mechanism that only the builder would have the key to. So that you don't get, well, I mean, it's pretty tall anyway, so the kids wouldn't really cause much of a hassle. But yeah, we broke it up into thirds so that the weight is more evenly distributed, so you're not taking out an entire panel on its own, but instead we start ones. They could get broken up even more if it turns out to be too heavy.
So it's bolted, you remove bolts to...
And the insert from the key center from the other side,
Yeah, yeah, for both the concrete and the steel one, they exit from the other side.
In this case, the beehive is a little bit, I mean, you know it when you're underneath, but not that in any of the proposals it's obvious that there's a beehive. But I guess in the other one, it's more clear, more clearly expressed if we are far in the park. Yeah, the strength here is also this integration. But then when you're designing these cuts, is that related to the structure? Why do they take these shapes?
It's related to the structure.
They could actually take any shape, it doesn't really matter, but we found it interesting that we relate to the structure.
How did you guys decide how big to make the hive itself?
Well, we wanted to keep it at least, I think it was 3 or 4 feet above the ground. Another thing was that, I guess actually that was really just the major concern we had, was that it wasn't too low. We also thought about maybe shifting it so that it's not symmetrical, but it might be leaning towards one side so that you can get, for example, eastern sun during the morning. So if the sun is coming from this direction towards here, this might shift a little bit, and that might be more efficient, might be better to use.
In terms of ventilation with this cavity for the leaves, you think only those small crystals kind of you think it's enough to address those small openings?
What do you guys plan for it?
Well, originally we had a lot of holes in the back, and then we remembered that you said they like the holes more condensed so that they can enter in from one space rather than like have these holes spread out. So I think right now we only had about like 8 holes in the back. Maybe, I'm not sure for like cross ventilation through this thing, if by putting exits on opposite sides that might help with ventilation.
Is it, are there like heat limits to what needs to be tolerated? This is going to get quite hot, isn't it? If they didn't.
What would you find if I were to say maybe there should be a little more ventilation? Would your solution be putting more holes in the steel, or
We'd probably try and think of a way where we could actually make ventilation holes, but not exit and entry holes.
Any last comments or questions for the team?
Could the whole arch be leafy?
Excuse me?
Could the whole arch be full of leaves? Rather than just in a specific place?
It could get lower, but that again is an issue with just like animals crawling up it, because then they'd be able to crawl up the whole structure because of the cross bracing inside of it. So it can come lower, but
I was just thinking about in terms of the two materials, because here you don't have that choice of concrete. You do have that choice of steel. It can be more or less, or lower or higher, or whatever. The point is interesting is to look at.
Okay, thank you.
show great sensitivity to our fair bees and also to the site that sort of was handed to you. I think there are 4 very great proposals and you know, very different. And so my hat remains on, which is long. But thank you guys.